All right, we're at section 20.4, adiabatic processes for an ideal gas. We see that the adiabatic process, we discussed this in chapter 19, I believe, 19.5, section 19.5. Adiabatic processes, an adiabatic process is one in which no energy is transferred by heat between a system and its surroundings. So D internal is equal to NCV because of the internal energy of an ideal gas depends only on temperature, the change in the internal energy in an adiabatic process is the same as for an isovolumetric process between the same temperatures. dE equals NCV dt, which is equation 2026. Hence, the first law of thermodynamics, delta E internal is equal to Q plus W, with Q equals 0. That means that it becomes the infinitesimal form, dE equals NCV dt, which is equal to minus PDV, which is the work. In other words, there's no Q, it's only the work. Now, let's we take the total difference of the equation of the state, and that gives the PDV plus VDP equals NR dt. So eliminating the dt, the equation becomes PDV plus VDP equals minus RCV PDV. And if we substitute R equals CP minus V and divide by PV, we get dV plus dP equals minus CP minus CV divided by CV dV dt equals 1 minus gamma dV over V. So dP over P plus gamma dV over V equals 0, which means that if we integrate this expression, we get natural logarithm of P plus gamma natural logarithm of V is constant, which gives us that pressure times volume to the gamma power is equal to a constant. Now here's the PV diagram for an adiabatic expansion is shown in figure 20 is shown here. The temperature of a gas decreases in an adiabatic expansion. You can see that it's much steeper than this T initial. Because the gamma is greater than 1, the PV curve is steeper than it would be for an isothermal expansion, for which PV is constant. By the definition of an adiabatic process, no energy is transferred by heat into or out of the system. Hence, from the first law, we see that delta E internal is negative. That is, work is done by the gas, so that its internal energy decreases. And so delta T also is negative. Therefore, the temperature of the gas decreases during adiabatic expansion. Conversely, the temperature increases if the gas is compressed adiabatically. Applying equation 2038, which is the PV to the gamma power equals a constant, P initial V initial gamma equals P final V final gamma. Using the ideal gas law, we can express this as TV gamma minus 1 is constant. And that's the end of that section. We'll go on with the next section, distribution of molecular speeds, in the final video for this chapter.